Right, day three.
Hey guys, welcome to day 3. Today you're going to learn all about conditional statements, if, else, elif, logical operators, code blocks, scope, global and local namespacing, and a whole lot more. And by the end of the day, you will know enough to be able to build this awesome choose your own adventure game. So this is what it looks like when it loads. And our mission is to find the treasure. So it tells us you're at a crossroad. Where do you want to go? Left or right? Let's say I want to go left. You come to a lake. There's an island in the middle of the lake. Type wait to wait for a boat. Type swim to swim across. I'm going to wait for a boat. You arrive at the island unharmed. There's a house with 3 doors, one red, one yellow, and one blue. Which color do you choose? Let's choose red. And unfortunately, it's a room full of fire. Game over. So this game lets the user make decisions, and depending on what they've chosen, it continues the game storyline. If you want to have a go at this game, you can head over to this URL or simply click on the link in the course resources and have a play around with the game. And once you're ready, head over to the next lesson and we're going to start picking up the skills that's going to be required in order to build this game. So I'll see you on the next lesson.
Alrighty.
Here's a question. Have you ever sat in your bath and wondered, why is it that no matter how forgetful I am, my bath never overflows like this? This is something I was thinking about the other day. And I realized that it's not because I'm particularly diligent. I forget stuff all the time. I mean, pizza, anyone? It's what my pizzas usually look like. Um, but the reason why our bathtub or the sink doesn't overflow is because of this fantastic piece of engineering, the overflow. So this means that whenever the water reaches beyond a certain level, about here, the water starts overflowing so that the bathtub doesn't overflow and annoy your neighbors downstairs. In fact, we could represent this mechanism with a conditional statement. When the water level is, say, greater than 80 centimeters, then it should drain the water. But if the water level is not greater than 80 centimeters, it should continue filling up the tub.
No,
This type
not
of
community
conditional
edition.
statement is known as an if-else statement.
Oh,
Depending
yeah,
on a
okay.
particular condition, we would do either A or B. And when we want to write Python code to represent this, it looks something like this. There's the keyword if, and then the condition that we're testing for, and then a colon. And after the colon, we've got an indented block of code which should be executed if this condition is met, if it's true. But if it's not true, then we will skip to the else block, and it's just the else keyword with a colon. And then this code block would execute if the condition is false. So we could represent that previous bathtub situation with code that looks a bit like this. Let's say our water level is at 50 centimeters, and then we would test if the water level is greater than 80 centimeters. Well, if that is the case, then we should drain the water. But if it's not greater than 80 centimeters, in other words, else, well, in this case, we should just continue filling up the bathtub. Let's put this into practice with a real life problem. Now, let's say that you've gotten a job at a theme park, and your first job of the day is to write some code that replaces the ticket box. Now, there's a couple of things that you'll need to think about. Firstly, in order for somebody to actually purchase a ticket to go on the roller coaster ride, they will need to be over 120 centimeters. So we have to check what their height is. because if they're too short, then we won't be able to sell them a ticket anyways. In the course resources, I've included a link to this flowchart that I've created on draw.io. This is a really useful tool for creating any sort of flowcharts or diagrams, and it's really easy to use. Now, if we take a look at this flowchart, this is basically the logic that we have to program using our if and else statements. If the person who's trying to purchase a ticket is not over 120 centimeters, then they can't ride on the roller coaster. But if their height is greater than 120 centimeters, then they can ride. So let's try it out. All that I've got here is a print statement that says welcome to the roller coaster, as well as an input asking the user for their height in centimeters, and then converting this string into a whole number, an integer. And then I'm storing it inside this variable called height. Now we're going to check whether if the height that the user has typed in is greater than 120. So we use the keyword if, and then we check if the height is greater than 120, and then we add the colon. And now when I hit enter, you'll notice that the code editor has automatically indented me slightly over. I'm not over here, because in Python, the spacing and indentation is really important. It tells the computer that the code that I'm about to write is what should be executed when this condition is met. So what should happen? If your height is over 120, then we will just print you can ride the roller coaster. But what should we print if height is not greater than 120? Well, in this case, we would use the else statement to catch when that happens. And it's really important that you don't write the else here, because this is indented over. Instead, you want it to be at the same indentation level as the if statement. These two are essentially a pair, if and else. Now, after the else keyword, we again add a colon, and then we hit enter, and we're now indented again. And here we can write the code that should happen if this condition is false. Sorry, you have to grow taller before you can ride. So the really important things here are the condition, which we're testing for, is the value of height greater than 120, the syntax of this code, so the keywords if and else, as well as the colons that come after each of these lines, and finally also the indentation. Everything that is indented after the if is a block of code. So this is indented and it's effectively inside this if. So this line of code lives inside the else statement. This block of code lives inside the if statement. And if you mess up on the indentation, then you're probably going to get an indentation error telling you that this line, 5, probably should be indented. But when we do actually correct it and we hit run, let's say that our height is 130 centimeters. Then we get back, you can ride the roller coaster. But if our height was, say, 90 centimeters, then we get a different outcome. We get, sorry, you have to grow taller before you can ride. So by using if and else statements, we're able to get our code to do different things,
Welcome to the
either
roller
printing
coaster.
this line
Sorry, you have to
or
grow taller.
printing this line, depending on a condition that we're testing for. Now, when we use this greater than sign, effectively what we're saying is that is the height greater than 120, which means that it does not include 120. In fact, if I run this code and if I type in my height as 120, then it actually goes into the else block and prints this. So if we wanted to include 120 centimeters so that all the people who are exactly 120 centimeters can ride the roller coaster, then instead of just using a greater than symbol, we have to write greater than or equals. So these two symbols have to be next to each other. And now when I run my code and I write 120, you'll see that it's now falling into this block of code and it's telling me that I can ride the roller coaster. Now, these are called comparison operators, and we've already seen greater than, so lesser than is pretty self-explanatory, but we've also seen greater than or equal to and lesser than or equal to. So if you want to include a particular number or particular value, when you do these comparisons, you would be using these instead. Now, in this table, there's also the equal to and not equal to. For example, if you wanted to check if somebody's height is equal to precisely 120, then you would use two equal signs. And very often it gets a little bit confusing, especially if you're new to programming, when you're typing equal signs, because sometimes we're typing 1 and other times we're typing 2. It's important to remember that when you have one equal sign, it means that you're assigning this value to this variable. But when you have two equal signs, you're checking to see if the value on the left is equal to the value on the right. And they're completely different. Now, the good thing is that when you get it wrong, usually you'll get enough clues in the error to actually hint to you, hey, maybe there's something that's wrong here, right? Because the syntax doesn't look right. For this to be a condition, it has to be something that evaluates to true or to false. And height equals 120 does not evaluate to either. So by changing it to this, we're saying if height is equal to 120, then we'll execute this line of code or any other lines which are in the same block of code. But if the height is not equal to 120, then we're going to execute this block of code. So if I write 120, then that works. But if I write 121, then it does not work. Similarly, you can also check for not equals to, which just flips it around. But in our case, it makes sense to say if the height is greater than or equals to 120, then you can ride the roller coaster, but otherwise you cannot ride the roller coaster. By using if and else statements, we can get our computer to do different things and respond differently depending on different conditions. So in the next lesson, I've got a coding exercise for you. I'll see you there. All right,
Well, this
in this
isn't a
lesson,
coding
we're going to
exercise.
learn about a new operator. So similar to the other mathematical operators and the conditional operators, an operator is just a symbol in programming that has a specific function. So what is the modulo operator? Well, it looks a bit like a percentage sign, but it's not just a percentage sign. Instead, it goes in between two numbers, so hence a binary operator, and it works out what is the remainder after the division. So 10 divided by 5 is equal to 2, and this division is clean because 5 goes into 10 two times, and there's no remainder. So therefore, 10 modulo 5, if we were to print this out, would give us the result of 0, no remainder in this division. So here's a challenge for you. What is 10 modulo 3? If 10 divided by 3 is 3.33333 recurring, because 10 does not divide cleanly into 3, what do you think would be the result of 10 modulo 3 on a computer? Pause and have a think about it. Okay, so let's go through the solution together. If 10 divided by 3 is equal to 3 with some decimal places, that means 10 does not divide cleanly into 3. 10 divided by 3 is equal to 3 with 1 as the remainder. So that means 10 modulo 3 is going to equal to 1, because all that the modulo does is it performs a division and then gives us how many is remaining after that division. So armed with that knowledge, you are now ready to tackle another coding challenge. And in this coding challenge, I want you to write some code to check whether the number inserted in the input area, so typed by a user, is odd or even. So you'll need to get hold of what they type in the input area. You'll need to convert it into an integer number, And then you'll need to use an if statement to check and see if you were to modulo that number, is it going to have a remainder? And remember that even numbers, when you use the modulo, so for example, let's take an even number, 12. If you use the modulo and you divide that number by 2, it's always going to be equal to 0, because any even number divided by 2 should divide cleanly. So if it divides cleanly with no remainder, then it is an even number. So have a think about this and see if you can complete this challenge. And then later on, in a minute, we will pause the video and then I will come back and explain the solution together. So give it a go now.
Alright, so based on that logic, we just need an if-else statement. She already gave us the criteria for an even number. So we want to get input. Alright. So we'll call our variable input number equals input. Please give a number. Cool. If input number modulo 2 is equivalent to, let's call it that, because this is equals, variable assign versus checking, anyways, is equivalent to 0, print even, else print odd, because there's only 2 options. So 3, okay, what did we do? Not all arguments converted during string formatting. Okay, so what we need is to typecast this to integer, I think. Hopefully. Cool. 3 is indeed odd. 4 is even. The only issue is this. What does this do with 1? Alright, well, 1 is odd. Cool. I don't know what this would do with 0. I mean, I guess 0 is neither even or odd, so whatever. And just for fun, -1 is odd. Let's see, -2. Okay, cool. Alright, looks good to me.
Okay, so the first thing we need to do is to get hold of an input. Now, it doesn't matter what you ask. You could say, what is the number you want to check? And this is going to come out onto here. And then once the user types a number, that number needs to be stored and converted into an integer. So let's do the type conversion first. And then let's create a variable called number to check and set it equal to this right hand side. So let's just confirm that that worked. Let's go ahead and hit run, type in a number, and it gets printed. So that's all working as expected. Now the next thing we need to do is to actually check the number. So if we print the number to check, modulo 2 to check if it's even, then we can try this out with some different inputs. So let's try 12. Modulo is 0. Now, what if we try a odd number? Let's try 3. Then we get modulo gives us an output of 1. So 3 modulo 2 has a remainder of 1, which means it's not even because it does not cleanly divide into 2. Let's try another odd number, 19. So you can see from this experiment or your knowledge of maths, whatever we take and we modulo it by 2, if it's equal to 0, if this result is equal to 0, then that means that this number is an even number. So instead of printing this, we can use an if statement. If number to check modulo 2 is equal to 0, colon. Now on a indented line of code, we can say print, well, this is obviously going to be an even number, and otherwise, so else, then we can print that this is a odd number. So let's just add one space here so that when I run this, my cursor just has one space beyond the question mark. Let's check some numbers. 45 is odd, which is true. 34 should be even. So this is reasonably simple, but it's also quite hard because it uses two things that you've learned and it combines them together. So hopefully you managed to get this to work and you managed to write the code yourself. If not, head back to your code and fix it so that it works after you have seen the solution. There's no shame in seeing the solution. It's all a part of the learning process. Don't worry if you didn't get it first time. There's a lot of things that I didn't get first time as well. But the important thing is you write down notes and you understand what is explained in the lessons so that you're ready to tackle the next challenge.
Nested if statements, huh?
In previous lessons, we learned about using the if and else statements to check whether if somebody is over 120 centimeters or not and allow them to actually purchase a ticket if they are over a certain height. Now, in addition to the height, there's another condition that we need to check for, namely their age. If somebody is over 18 years old, then they should be paying the adult price, which is, let's say, $12. But if they are 18 or under, then they should only be paying $7. So how can we represent this extra condition that we need to check for in our code? Well, we could use something called a nested if-else statement. We've seen our if-else statements look like this, where it's only got two choices. If this condition is true, do this, otherwise do that. But in a nested if statement, once the first condition has passed, we can check for another condition. And then we can have another if-else statement inside this if condition. In order for this thing to happen, this has to be true and this also has to be true. In order for this to happen, this condition has to be true, but this condition has to be false. So essentially, the computer first looks at the larger picture, which is this first condition, and decides on whether if it should go into the else block here, or if it should go into the nested block inside the if statement. So now this is what our flowchart looks like. In the first if statement, we check whether if their height is over 120 centimeters. If no, then the if statements all end. You can't ride, you can't buy a ticket. But if yes, we actually take them to yet another if statement where we check their age. If their age is 18 or under, then we give them a $7 ticket. If they're over 18, then they have to pay $12. So the place where we're going to nest our if statement is inside here. Notice how it's indented, so it's already inside this if block, and this already has to be true. Now here we're going to create another if and else statement, and the condition checks for their age, so we better ask them for an age. let's say age equals, convert the input to an int, and what is your age? So now that we've gotten hold of their age, we can see if their age is less than or equal to 18, well, in this case, we're going to give them the $7 ticket. But else, namely, if this is not true, if their age is over 18, well, in that case, we're going to give them the $12 ticket. So now we have a nested if statement because this if and else statement lives inside this if statement. So this condition will only be checked if this is already deemed to be true. Now let's say our situation got a little bit more complex. The boss comes over, checks our code, and says, wait. There's actually more price tiers than that. In fact, if you're less than 12 years old, you pay $5. If you're between 12 and 18, you pay $7. And if you're over 18, then you pay the full adult price, which is $12. Now, there are three possibilities. So how do we represent this in our if statement? Well, we could use something called the elif. Instead of having a simple if-else statement where there's only one condition, if it's true, do this, otherwise do that, you can add as many elif conditions as you want. So we can check for condition 1. If that's true, then do A. But if that's not true, then we can continue and check for condition 2. If condition 2 is true, well, then we can do B. And finally, if none of those conditions were true, we can do this final thing. Our flowchart now looks something like this. And this is the logic that we're trying to program. Once we're inside this nested if statement, we're going to check if their age is under 12, in which case they should pay $5. If they're between 12 and 18, then they should pay $7. And finally, if they're over 18, then they should pay $12. Now, the first thing I'm going to check is if the age is less than 12. Under this condition, they should pay $5. So let's change that to 5. Now, the next condition should be created using an elif, which stands for else if. So it means if this is not true, else if, can you check if this is true? Well, in that case, then we should do this. For example, if the age is not less than 12, so they're over 12, then are they under 18? Well, then this condition basically catches everybody who's between 12 and 18. And finally, if they're not less than or equal to 18 and they're not less than 12, then that's everybody else who is over 18. Now, remember that we can use as many elif conditions between the if and else as we like. So I could add another elif that checks whether if the age is less than, say, 22. Well, in this case, do something else. And then I can keep going with these elifs until I'm done with all my conditions. So have a play around with this code, write it yourself, see if it makes sense, and then mess around with the elifs so that it does what you expect it to do. And then once you're ready, go ahead and head over to the next lesson where I've got a coding challenge for you.
And that all seems pretty straightforward to me, I think. Yeah, I've already done this, but we're going to reset it, and that's fine. All right. Write your code below. Add some if, elif, else statements. All right. If BMI is under, not including, 18.5, print underweight. They do no capitalization, which is annoying, but if BMI. Alright, so the if statement is anything below 18.5. So 18.4 all the way down to negative infinity. Uh, and then 18.5, we want to go up to 25, but not including. So we'll just less than 25, because everything before that is caught in the if statement. Um, Print normal weight, else should be fine, uh, because everything else is going to be above all of that. And that will be, according to this, overweight. Run code. Uh, I wish it showed the BMI. Let's just see. Print. I think we did this earlier, or a day or two ago. I can't remember at this point. BMI. It was either the first day or yesterday. So 24.8, which is indeed just under 25. Looks good to me. Run tests just to be sure, and cool.
Now, in the last lesson, we saw how we could use if, elif, else to check for multiple conditions. But in this case, we're only checking one condition, even though we have multiple. Because if this first condition is true, then we would do whatever it is we need to do, and then we would bypass everything else. Now, what if you're in a situation where you need to check for multiple conditions, even if the previous one was already true? Coming back to our roller coaster ticketing problem, if you're going on a good roller coaster ride, you'd probably want to keep a picture for the memories, right? And our roller coaster is no exception. We want to be able to charge users an extra $3 if they want to purchase a ticket that includes a photo. Now, this is quite interesting because this is completely independent of their age or their height. Even if we've already gotten their age and height and determined their ticket price, this is an extra question. Do you want a photo or not? Yes or no? If you do, then we're going to add $3 to your existing ticket price. To do this, we would write multiple if conditions. If condition 1 is true, then do A, but then the code is going to go to the next case and check if condition 2 is also true, in which case it will do B, and if the final condition is also true, it's going to do C. Whereas on the example on the left here, only one of these things, A, B, or C, will be carried out. Comparing the example on the left, where we're using if, elif, else, only one of these things, A, B, or C, will be carried out. But on the right-hand side, all three conditions are checked. And if it so happens that all three conditions are true, then A, B, and C will all be executed. Currently, our code operates like this. We check for their height. If they're over 120 centimeters, we check their age. And depending on their age, we give them a different price ticket. What we now want is, even after we've checked for their ticket price, we want to ask them a question. Do you want photos with your ticket? And if the answer is yes, then we're going to add $3 to their bill, no matter which type of ticket they've got. And finally, we give them the total bill. If they say no, then we jump straight to the total bill and just tell them the price of their ticket. So, how do we implement this in our code? Well, first, let's change these print statements. Instead of giving them the bill at each of these steps, I'm going to tell them which type of ticket they're eligible for. So the next thing to do is to ask them whether if they want a photo or not. So I'm going to need to use an input. But the question is, where do I put that? Now, the correct answer is that it has to be at the same indentation level as this if block. So you can imagine this whole thing with the if, elif, and else as sort of belonging together because they all relate to one thing. What is their age and which type of ticket are they eligible for? Now, outside of that if statement, I'm going to create an input and ask the user, do you want a photo taken? Type Y for yes or N for no. And then I'm going to save their input inside a variable called wants photo. So now I'm going to use an if statement to check what their answer was. If it was true, then I'm going to add $3, and if it was false, I'm just going to skip to giving them their ticket price. So here is where I write my if statement. Notice how it's at the same indentation level as this previous set of if statements, but it's not at the same indentation level as this set of if statement. So essentially what's happening is once I've checked their age, then I'm going to check whether if they want a photo or not. And this is going to apply to everybody, no matter their age. So if wants photo is equal to Y, well, in this case, I'm going to go and add $3 to their bill. But how can I add $3 to the bill when I don't have a variable to vary? So instead of using these print statements, I'm going to create a variable up here called bill, and I'm going to set it to equal 0. Now, in addition to printing to the user how much their ticket is, I'm going to set the bill to the price that they're supposed to pay. So if age is less than 12, bill is equal to 5. If age is less than 18, then bill is equal to 7. And finally, for everybody else, the bill is equal to 12. So now, depending on these conditions, the variable bill is going to be changed to a different number. But once we land in this if statement, I'm going to have to add $3 to their bill, no matter which value it is at the moment. So effectively, what I want to do is bill equals the current value of bill plus 3. So if bill was 7, then this new value of bill should be 10. If bill was 12, then it should now be 15. Now in Python, as well as many other languages, there's actually a slightly shorter way of writing this. When you want to
Plus
increase the current
equals.
value that's held in a variable and you want to save it back into the variable, you can simply write plus equals. So bill plus equals 3 is the same as bill equals bill plus 3. Now, no matter what the value of bill is before it reached this if statement, I'm still going to add $3 to it. Now, after this if statement is completed, I don't actually have to write a companion else statement because in this case, if the answer is no, then we're simply going to do nothing. We're not going to do anything to the bill. Instead, I'm just going to skip ahead and print to the user their final bill. And I'm going to use f strings to insert the value that the bill variable has into this print statement. Now, for your code to work, the indentation matters a huge deal because the computer will think you want it to do different things depending on the indentation. So notice how this indentation shows that this bill plus 3 is to be executed when this condition is true. But this print statement is not indented to the same level. And effectively, it's going to happen after this if statement has been executed. So you can play around with indenting this print statement, unindenting it, and see what the difference is. But now I'm going to go ahead and run my code and try and get a ticket. So let's say that I am 21 years old, tells me that adult tickets are $12, and then it asks me, do you want a photo taken? So yeah, I would love to have a photo taken. And it tells me that my final bill is 15. So I forgot a dollar sign here, but effectively it's now added the $3 to the $12 because of this additional if statement. So if this concept is still a little bit confusing to you, then I want you to really study this flowchart and just look at the difference and visualize it. Because the if, elif, else statement is only ever going to be true in one of these arrows, right? You can't be less than 12 and 18 and over. And similarly, it doesn't make sense for you to have two different ticket prices. But with the want photos, this condition has to be asked no matter whichever branch they landed on. So it's completely separate from this if statement. And once you've had a look at this flowchart, then compare it against the code. And the way that the code works should be a lot more obvious. And once you're happy with the code and this concept, then I want you to head over to the next lesson where I've got a code challenge for you. So for all of that and more, I'll see you there.
Pizza
Alright
order
guys, in this lesson
practice.
I have a small coding challenge for you. The goal is to create a Python pizza delivery program, and the program is going to automatically calculate the bill for the user based on a number of options. So the user is going to be asked 3 questions in the form of an input, and we can run through this program as it is just to see that in action. So firstly it says, welcome to Python pizza deliveries. What size pizza do you want? And I'm going to choose a large pizza. So it asks me S, M or L. So L. Do you want pepperoni on your pizza? Yes, always. And then it asks, do you want extra cheese? I'll type N for no. So these are my inputs, which will get saved into these variables: size, pepperoni, and extra cheese. And what I want to happen is for us to be able to print out the final bill saying your final bill is this amount, and it should be $28 based on the pricing of Python pizza. So you can see in the description box here we've got all the prices for small, medium, large pizzas, as well as the modifiers. So if they want pepperoni on a small pizza, that's an extra $2. If they want pepperoni on a medium or large pizza, that's an extra $3. And finally, if they want extra cheese, that's $1 on top of their bill. So your goal is to use what you've learned about if statements, elif statements, else statements, nested if statements, multiple if statements, everything you've learned so far basically in today's lessons to be able to build this and get it to do what we expect it to do. So pause the video, have a think about how you might tackle this problem and work through each of the to-dos in order. Afterwards, come back and we'll go through the solution together. By the way, in this lesson, you can click on the check button once you think your code is doing what it's supposed to, and we'll run through the automatic test using various options that we've tried for size, pepperoni, and extra cheese to verify that your code works. So pause the video now.
Okay, why don't I have those prompts that she has? Oh well, don't need them anyways. Okay. Congratulations. Based on a user's order, work out their final bill. Use the input function to get a user's preferences. We've already got those up there. And then add up the total for their order and tell them how much they have to pay. Alright, so I guess we'll start with if calculate the, I guess we'll want a total equals 0 if size is equal to s, total plus equals 15, because that's what we have over here. Now if size is equal to m, our total is going to plus equals 20, if size equal to large, plus equals 25. And I did that as an elif because else, uh, you know, it's not a valid input. And let's just print invalid input. How about that? Yeah. Um, Now we're moving on to adding pepperoni. If pepperoni is equal to y, total, that's right. Uh, we want to also check if size is equal to s. So if pepperoni is equal to y, and you could say and, if I think if the size of, or if adding additional pepperoni is yes, and if the size is small, then total plus equals 2. If, oh, never mind, we're still in yes. If size is equal to medium, total plus equals 3. If size to large, total plus equals 3 else. Alright, print invalid input. I know it's not very good input handling or whatever you want to call it, but it's better than nothing. Else, yeah, no, we don't need an else, I don't think. If extra cheese, oh, this is the one that has extra. The other was just do I want pepperoni. If extra cheese equals yes, total plus equals 1, because it doesn't matter what size pizza it is. Alright, I think that should be it. Print, do an F string, your final bill is $, curly braces, total. Cool. I think that should be it. Let's run it. I want a medium pizza, which is $20. Of course, I want pepperoni, which is going to be an additional $2. And you know what? I want some extra cheese as well, so this should be 20. That's right. I had a medium pizza, which is an extra $3 for pepperoni. So, yep, looks good to me. Let's see what the check thinks. Failed 3. Okay. Forgot the period. Cool. Uh, yeah, no. All right. I mean, I found the solution, but we'll still watch this.
Alright, so let's run through the solution together. The first thing we want to do is to work out how much they need to pay based on their size choice. So we've got all the prices here, and we're going to start off with a variable called bill that's going to start out at 0. And we're going to check the variable size. So if the size that they chose is equal to S, that means they wanted a small pizza. So then to the bill, we will simply add $15. Now, at this point, because this is the very first if statement and we're simply setting the bill depending on the size that they chose, you might have done it differently. You might have done this. You might have said, let's set the bill to equal 15 instead of plus equals. Both of them work and both of them are acceptable solutions. Now, I'm going to stick to using the plus equals because we're going to be using it a lot in this program. So hopefully you already understand that this is the same as saying plus 15 to the previous value of bill and set it to the new value. So the next thing we need to check is what if they chose a medium-sized pizza? So we're going to use elif and we're going to check the second condition. If size that they chose is equal to m, in this case we're going to add $20 to the bill. So we're going to say bill plus equals 20. And the final version, so the L, if they chose a large pizza, we need to set it to $25. Now, there's two options here. You might have done an L statement because we've already tackled S and M. The last one is just L. So we could simply set the bill is equal to plus equals 25. But you might have also added another elif statement. So again, both of these options work. We can say elif size equals L. Depends on what you want to choose, but both of these options will work just fine. Now, you might also want to add a final else statement if you are really careful, because what if they typed something wrong? What if they typed instead of S, M, and L, they typed some mumbo jumbo? Well, that would be tackled in the else statement, and you could print out you typed the wrong inputs just to catch that situation. Now, I have a warning sign under my print statement, and it tells me that my indentation is not a multiple of 4. So just in case this happens to you, just make sure that every time you use an indent that you've got 4 spaces in there. So if I just add one more space and make sure that all of these are on the same indentation line, that warning goes away. So we're done with the first to do. We've worked out how much to add to the bill based on the user's size choice. The next thing to do is to figure out if they chose any pepperoni. So if pepperoni is equal to y, then in that case we need to add some money to their bill. But how much? Well, it depends on the size of their previous choice. So if they had a small pizza, it's $2, and if they had a large pizza, it's $3. So the easiest way to do this is to use a nested if statement. So inside the previous if statement, we've already checked to make sure that they chose Y for pepperoni, so yes to pepperoni. If we add another if statement here, this will only be checked if they already said they wanted pepperoni. So if the size is equal to S, then this is the case of a pepperoni on a small size pizza. So to the bill, we can add $2. Now, else, so they chose yes to pepperoni, but they have a different size, then we can say the bill should add equal $3. And that solves the pepperoni problem with a nested if statement inside another if statement. So the final to do is to work out their final amount based on whether if they want extra cheese. So this is a situation where we have multiple if statements. So we have an if statement here that's being checked, we have an if statement here that's being checked, and finally we have an if statement that checks if they want extra cheese. So if this is equal to yes, then all we need to do is add the $1 to the bill. And that is all we need to do to complete this last addition. And now we can finally print out the value where we say your final bill is, and then colon, and then a $sign, and then we're going to use an F string to insert the amount for our bill right here. And finally, we need a full stop. Now, make sure that you've actually got everything written exactly as I have, because otherwise the checks are not going to pass. So now that I've made sure I've got all the right full stops and all the right wording, and hopefully my calculations are correct, I can now click on check, and if everything is correct, then it tells me, congratulations, everything's correct. So hopefully that wasn't too hard and you managed to figure it out by yourself. If not, this is the time to go back and fix your code based on what you've learned in the solutions. We all make mistakes and we all need help to figure out things. There is nothing wrong with learning from the solution walkthrough as long as you understand everything that's going on. So go ahead and do that if you need to. Otherwise, head over to the next lesson where we're going to learn about logical operators. Now, up to this point, you've seen us use if statements, else statements, elif statements, multiple if statements, as well as nested if statements. But the thing that we haven't been able to do thus far is to check for multiple conditions in the same line of code. So how would we be able to combine different conditions and say, well, is the pizza large and the user wants pepperoni and extra cheese all in the same line of code? Well, to do this, we would need to learn about the logical operators. So there's 3 of them that are really useful, and, or, and not. So let's take a look at the first one. When you combine 2 different conditions using an AND operator, they both have to be true, both A and B, for the entire line of code to be true. If just one of them is true, say A is true and B is false, or A is false and B is true, then the overall thing evaluates to false. Now let's try out some of that in actual code. So let's go ahead and go into the Python console that you see right here. And here we can write Python code from scratch, so completely independent of everything else and independent of our code files. So let's test out some Python code in here. Let's say that A equals 12, right? Now, let's say that I wanted to check whether if is A greater than 15? Well, that is going to be false. Now, what about is A greater than 10? Well, that's going to be true. Now, if I combined this using an AND statement, I could say, well, is A greater than 10 and A is less than 13 and hit enter, then I would get true because both A is greater than 10 and A is less than 13 are true. So in this case, when both conditions are true, then this entire line gets evaluated to true. But see what happens when just one of them is false. So is A greater than 15 and A less than 13? A is greater than 15 is false, A is less than 13 is true, and now we get false. So that's what happens when you combine different conditions using AND.
So using the AND logical operator, it looks at two conditions and to see if they are both true. And if they are both true, it becomes true as the final outcome. But if either of these are false, so false and true becomes false, true and false also becomes false. And this is how the AND logical operator works.
Now, if you only needed one of the conditions to be true, then you could use the OR operator instead. So if C or D were true, or if they're both true, then it would evaluate to true. It's only when both C and D are false does this statement actually become false. Now the final one is the NOT operator. And all that this does is it basically reverses a condition. So if the condition is false, then it becomes true. If it's true, then it becomes false.
So coming back to our code, we can refresh and restart the Python console and start with the same a equals 12. And we can use the OR statement by saying, well, is a greater than 10? That's true. Or is a less than 10, which is not true. So here we have a condition that is true and a condition that's not true, but because this time instead of using an AND, we have an OR between these two conditions, then this will actually evaluate to true. So in this case, using the OR, true or true will become true. True or false will become true. False or true becomes true, and it's only false or false when both of the conditions are false does it actually evaluate to false. So this is quite different from the AND operator. Now, finally, with the NOT operator, it only works when the condition that's being checked is false. So effectively, it flips the true to the false and false to true. Let me show you what I mean. So we know that A is 12. So is A less than 0? Well, it's not because it's 12. It's definitely not less than 0. But by putting the not in front of it, it reverses the condition. So A is less than 0, this will evaluate to false, but putting the not in front of it, it becomes true. So not false is true and not true is false.
Coming back to our roller coaster ticketing, let's say that the roller coaster company decided that for everybody who was having a midlife crisis, they would give them free tickets. And according to Wikipedia, midlife crises typically occur when you're 45 to 55 years old. Let's see if we can incorporate this into our code. So let's say that in addition to these existing price categories, what if you had to add a separate price category for those people who are aged between 45 and 55, and those people get to ride for free? Do you think you would be able to change the code using what you've learned about logical operators in order to incorporate this addition to our program? Pause the video and give that a go.
Well, yeah, you would just add an elif for elif age is greater than or equal to 45 and age is less than or equal to 55. Total plus equals 0. Yeah. I don't think there's anything else in here for, yeah, no. Because the next one is just, yeah, that's it.
So we've currently got 3 conditions: age less than 12, age between 12 and 18, and finally everybody else. Now, instead of just finishing up there, let's go ahead and add another elif. And here we're going to combine two conditions. We're going to say if the age is greater than or equal to 45 and the age is less than or equal to 55, then we get to catch that midlife crisis window. Well, in this case, we're going to print something like, we're going to say everything's going to be okay, have a free ride on us. And in fact, we don't need to modify the bill in any way because we know that with if, elif, and else statements is that once this condition matches, then everything that's inside this block, so everything that's indented inside this elif, is going to be carried out, namely printing this out, and then it's going to skip the rest of this if-else block and continue on. Now, if they want a photo, they still have to pay $3, but at least their ticket is free. And we've been able to do this because we know about the AND logical operator.
Now, for the keen-eyed amongst you, you might have noticed with this condition check, we have a warning underneath it. And this says that there's actually a simpler way of writing this expression. And it tells us that we can actually simplify it. Now, because we're checking two conditions and we have the AND logical operator in between, sometimes you might want to make this code less wordy. So if you hover over this warning and you click on Simplify Chain Comparison, it will give you a simpler way of doing this comparison using two of these checks either side of the age. And it does exactly the same thing, but in less words of code. But here is the big but. Looking at this, is this easier to understand and logic through versus this? Because to somebody who's just starting Python programming, I think this is easier to understand what's going on. Is age greater or equal to 45 and is age less than or equal to 55? So even though there is this warning in here, I'm going to leave it in this format because a lot of you are just starting out learning how to code, and this is a much easier way of reasoning about what's going on in this line of code. So the thing with warnings are that they're really helpful once you get going as a programmer, but in the learning stage, I wouldn't worry too much about all of it. Look at it, read it, see if you understand what it's trying to tell you, and then you decide which version you prefer.
All right. What will the following code evaluate to? Not 5 is equivalent to 5. So 5 is equivalent to 5, so that is true. But not true is false. Cool. What will the following code evaluate to? False, or true, or false? Well, it just needs 1 to be true. 1 is true. Cool. What will the following code print? If, alright, A is equal to 5, B is equal to 7. If 5 is greater than or equal to B, which is 7, 5 is not greater than or equal to. So we can go ahead and skip all of this. Elif A is greater than or equal to B. It is not. This is false. That makes this, the not makes it true. And A is not equal to B. It is not equal to B. So we print B. Easy peasy. Right? Okay.
finally, you've reached the final project. And as you've seen at the beginning of today's lessons, I showed you what we're going to be making, which is a sort of choose your own adventure game. I don't know if you've ever read those choose your own adventure books where you flip to a different page if you make a particular choice, and then the story kind of evolves as you make your choices. Now, we're going to make a very simple version of that using what we've learned about conditionals, if, else, elif statements, as well as everything we've done previously. So you've already seen what the final outcome should look like, and if you want to review it again,
Just head over to the link in the URL box or click in the course resources and it'll direct link you here.
and here you'll see essentially the game in action. So it start off asking you, you're at a crossroad, do you want to go left or right? And then you have to type your choice. If you selected left, then it's going to take you to a lake, and it asks you whether if you want to wait for a boat or swim across. So let's go ahead and wait for a boat. And then the final step is it asks you which door would you like to go through, red, yellow, or blue. Now, depending on your choice, you'll either end up with game over or you'll end up with winning the game. So the basic setup for this game looks something like this.
And I've included a link to the flowchart in the starting project right here.
And of course, you'll find all the links in the course resources as always. Now, the first question you're going to ask the user is to make a choice between left and right. Now, you can use my wording if you want. You're at a crossroad, where do you want to go? Type left or type right. But I think the fun part of this challenge is really creating your own story, right? But somehow get them to choose between left and right. If they choose right, or any other condition for that matter, tell them that they've lost, game over, for some sort of reason. In my case, if they had chosen right, the reason is because they fell into a hole, game over. But I think you're far more imaginative than I am, so go ahead and use all of those skills and make your game really fun. Now, if they've chosen left on the other hand, then we're going to take them to another question that asks them whether if they want to swim or whether if they want to wait for a boat. And if they swam, then it's going to be some form of game over. There's crocodiles, there's whatever it may be, but they can't continue. But if they chose wait, then we take them to the third and final question, which asks them to choose between 3 doors. And if they choose any door other than the yellow door, then they would lose, but if they chose the yellow door, then they somehow win. Now, notice how each of these just says game over, left or right, but the idea is really to use your creativity and make this game really your own. Now, one thing to remember though is that when the user types in a answer, let's say left or right, they might type it like this with an uppercase R, or they might type it like this, all lowercase. Have a think about how you might make sure that no matter which version they typed, you're still going to be able to catch their command, essentially. So have a think about what you've learned in the previous lessons and take a look at this flowchart. Then head over to the starting project and you can get started writing your code. Now, ASCII-R is really cool because it basically just uses a bunch of characters that you know and love, like the comma and the equal sign and all of these things that together make up a picture. And you can find your own ASCII art if you just go to ascii.co.uk/art, and you'll see a whole bunch of different topics, and they've grouped a lot of things together into individual pages. So if you wanted a rhino ASCII art, then you can find a whole bunch of rhinos that people have drawn. But the easiest way is, of course, using Command F if you're on a Mac or Control F if you're on a Windows machine, and then just search for the thing that you want. So, for example, I went and searched for treasure, and down here I found this brilliant treasure box ASCII art, which is what I'm using to print inside this print statement.
Turn image
Now,
to
notice
ASCII
how
art.
there's 3 single quotes that are at the start, and there's 3 single quotes at
Alright,
the
where
end.
can I search?
Basically, what the single quotes allow you to do is to create multiple lines of a string, essentially. So notice how if I go ahead and delete all of these single quotes, and I only had a set of double quotes, then it actually doesn't quite work. It gets quite confused because it thinks that this is where the line ends, but in fact I wanted to print all of this out. So to do that, instead
I
of
just want a
using a
door.
double quote, I use 3 single quotes, and at the very bottom I tell it, well, this is the end of my multi-block string by using 3 single quotes as well. So have a go at running that, and you should be able to see that in your console you get this little Treasure Island ASCII art being printed along with the 2 sentences that begin the game. So have a look at the flowchart, have a play around with the ASCII art, and also have a look at the final
Yeah,
version of the app so that you can go ahead and create.
close enough. I'm really not happy with those door ASCII arts, but I also don't really feel like making my own because that sounds tedious. Not for day 3 at least. Um, Now this says welcome to Treasure Island. I don't think I want to start uh, at Treasure Island. I think we're going to start somewhere else. Is to find the treasure. So we are going to find the treasure, but welcome to Path. Uh, Paths to Treasure Island. Cool. Um, Alright, so you wake up and you're on the set of a game show. In front of you are 3 doors. Which door do you choose? 1, 2. Alright, and we're going to save this input. Door choice. Oops. Let's see if door choice is equal to 1. And you open the door. And inside is, let's go with mountains and pools of money. The door closes behind you. You backslash in is for a new line. You look around, and there are no other ways out. Game over. It could be another. You open the door, and it is a movie theater. You sit down to a luxury recliner with the largest bag of popcorn you've ever seen. For the next 60 years, the optimal, the life you wish you had plays on the screen. Game over. Elif door choice equal to 3. Let's see. Hmm. You open the door and inside and find yourself inside of a flying plane. Somehow, you now have a parachute. We can fit more in here. A man standing by an open doorway is counting down. Before you know it, he reaches 0 and yells, "Go." I don't think it's gonna like that. What do you do? Tate. Sure, that's good enough. But we actually need lower. I want to say that's. I'll say this will work, but what we need is input. Um, choice 2, we'll call that. If choice 2 equals, you know what, let's make sure that dot lower works. Print choice 2. We want to pick door 3. Well, that didn't print. Hmm. Because we need these to be strings. Jump. So let's do it in all uppercase. Cool. Alright. That is what we were expecting for it to be in all lowercase. If choice 2 is equal hesitate, all lowercase, if choice 2 is equal to jump, print a bird flies into uh, 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 see everyone around, including the pilot, looking confused, and then game over. Print you free fall. Pull your parachute and somehow land safely on the only island around for 1,000 miles. The island is food and wildlife and great company for you to spend the rest of your days with. Print. Congratulations, you win. It ain't perfect, but 2. Alright, yep. Does what we expect. 1. Does what we expect. 3. Citate. Plane drops altitude rapidly. Let's actually call this. No. 3. Jump. Cool. It's nothing fancy. I probably should have done more error handling, input handling, but good enough for me. Yeah, I don't think there's any point in watching the rest of her solution video, but yeah, that's just another 15 minutes for no reason. So either way, I think, yeah, one more video.
Hey, I hope you had fun building the Treasure Island project. Now, remember that the most important thing when it comes to programming and learning this new skill is to really make the code your own. So with this project, really the sky's the limit. You can take your creativity and run with it. Make the story your own, change it up, change the game. Make it something that you imagine it to be. And I can't wait to play your game. So once you've created your own version, be sure to share it in the comments below so we can all play it and we can all admire your hard work. So have a go at that, and I'll see you tomorrow.
All right.
Hey.
And that's it for day 3. Randomization and Python lists will come up tomorrow. See you then.